the total time required by an object to reach the maximum height and to come back again to the ground is called as time of flight. Change in velocity is given by delta V. So in this, delta V represents the change in velocity. We have derived the relation between the linear velocity and angular velocity, and that equation is nothing but V is equal to R omega. Velocity is nothing but the change in position with respect to time. That is nothing but dr divided by dt. Hello everyone, welcome to session 5 of chapter 4, Motion in a Plane. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. So in the last session, we were discussing about the derivation of maximum height, which means in a projectile motion, if an object thrown into a space, what is the maximum vertical position the object can go? How can we find the maximum height with an expression is what we have already derived in the last class. And even we derived an expression for range. So what is range? It is nothing but the maximum horizontal distance covered by an object in a projectile motion. And also we have derived an expression for time of flight. The total time required by an object to reach the maximum height and to come back again to the ground is called as time of flight. So we have derived an expression for all these terms which are related to projectile motion, and those terms helps us to solve numericals in this chapter. And even we have derived a relation between linear and angular velocity, and the relation is nothing but V is equal to R omega, where V is nothing but the linear velocity and omega is the angular velocity. So in today's session, we are now defining centripetal acceleration, and let us derive an expression for the centripetal acceleration. So what is centripetal acceleration? So look at this diagram carefully. So centripetal acceleration is nothing but in uniform circular motion, the acceleration produced on a body acts along radius and it always directs towards the center. So if the body is undergoing uniform circular motion, the acceleration that is produced on the body that acts along the radius of it and it is always directed towards the center. So we will call it as centripetal acceleration, or we will also call it as radial acceleration. So centripetal acceleration and radial acceleration both are same. Whenever the body is undergoing uniform circular motion, the acceleration produced on the body that acts along radius and it is always directed towards the center of the circular path. And such type of acceleration is called as centripetal acceleration. So let us consider a particle of mass m which is moving along the circumference of circular path. So circumference of circular path. So it is having a radius r. So let us consider this r1 and r2 are the position vectors and they are moving with the velocities v1 and v2. So here the circumference of the circular path of radius r with uniform angular velocity omega or with constant speed v. The body is travelling along the circumference of the circular path which is having uniform angular velocity omega, and the radius of this is given by r. As I told, let us consider r1 and r2 be the position vectors and v1 and v2 be the velocities of particle at p and q as shown in the figure. So now let us write the tangent at p and q. So what does this tangent indicates? The tangent drawn at p and q shows the direction of the velocity. So here the tangent, if we write, it shows the direction of velocity. We know velocity is a vector quantity which has both magnitude and direction. So I have told you velocity is v1 at p, velocity is v2 at q, and the change in velocity is given by delta v. So in this, delta v represents the change in velocity. So whenever the body is moving in a circular motion, the velocity is also changing, as well as there is a angular displacement. So now with the help of all these data, let us derive an expression for centripetal acceleration. Now the magnitude of acceleration is nothing but vector A is equal to limit delta t tends to 0. What is delta t tends to 0? In a very small interval, rate of change of velocity is nothing but acceleration. Since we are writing an expression for acceleration, the acceleration is defined as change in velocity per time, that is delta V divided by delta T. So here velocity is also a vector quantity, acceleration is also a vector quantity. So it is denoted by a symbol vector on top of acceleration and velocity. So now you have to observe the diagram carefully. So this triangle CPQ is formed by the position vectors and the triangle GHI is formed by the velocity vectors. So these two triangles are similar. Since they are similar, we can write delta V divided by V, which is equal to delta R divided by R, where vector V represents the velocity and delta R represents the position vector, the change in the position. Delta V represents change in velocity, V represents velocity, R represents position. So from this, what we can write, delta V is equal to, take this V to the other side, we will get V into delta R divided by R. So that is our second equation. Now let us substitute the second equation, which means the value of delta V in our first equation. So first equation is nothing but the equation of acceleration. So what do we get? We get acceleration is equal to limit delta T tends to 0, delta V vector divided by delta T is our equation. Now in this equation, we are replacing this delta V by V into delta R divided by R. So let us write now, vector A is equal to limit delta T tends to 0, V into delta R divided by R is our delta V term. And we have delta T here, writing the same. So now we have V into delta R divided by R into delta T. But what is this delta R divided by delta T? Delta R divided by delta T is nothing but change in position with respect to time. Change in position is nothing but the body is getting displaced, which means the rate of change of displacement is nothing but velocity. So we can replace this entire term by the velocity term, that is V. So now V into V is V square divided by R. So from this, what we can write, A is equal to V square divided by R. We have derived the relation between the linear velocity and angular velocity, and that equation is nothing but V is equal to R omega. Now we have V square here. So let us substitute V is equal to R omega term in the place of V square, and we have V square divided by R. So let us substitute this R omega here and we get R square omega square divided by R. Now this R and one R gets cancelled and we remain with A is equal to R omega square is the expression for centripetal acceleration. So that is all about the expression for the centripetal acceleration. Now let us move on to numerical part. So let us now look into the list of formulae what we have discussed in this chapter. So as we all know, velocity is nothing but the change in position with respect to time. That is nothing but dr divided by dt. So what is acceleration? Rate of change of velocity. So it is given by dv divided by dt. And even we have derived an expression for height, that is maximum height of a object when it is in projectile motion, that is h is equal to u square sin square theta divided by 2g, where u is the initial velocity, theta is the angle of projection, g is acceleration due to gravity. We even derived an expression for horizontal distance, that is range. It is given by u square sin 2 theta divided by g. Here also u is nothing but the initial velocity, theta is the angle of projection. So next we have derived time of ascent or descent, which is given by small t, that is u sin theta divided by g. Time of flight is nothing but time taken by the object to reach the height to come back again to the ground. So it is nothing but time of ascent plus time of descent, that is 2t, and it is given by 2u into sin theta divided by g. So next we have a resultant vector formula. Magnitude of the resultant can be calculated by r is equal to root of a square plus b square plus 2ab cos theta. Sometimes we also use in terms of p and q, that can be written as root of p square plus q square plus 2pq cos theta. Next we have an expression to define direction, that is alpha is equal to tan inverse of b sin theta divided by a plus b cos theta, or it can be written as alpha is equal to tan inverse of q sin theta divided by p plus q cos theta. Both are same. So you can either use this or this. Only the terms are different. So we even derived just now the expression for centripetal acceleration, which is given by A is equal to V square divided by R. So we know V is equal to R omega. So substituting this, we get A is equal to R square omega square divided by R. And the centripetal force is given by F is equal to mv square divided by R. Because we know F is equal to ma and A is nothing but V square by R. So we can write centripetal force as mv square divided by R. Now let us solve the problems. So our first problem is position vector is denoted by the letter R. So the position of a particle is given by R equals 3t I cap minus 2t square j cap plus 4k cap, where t is in seconds and R is in meter. So we have to find the expression for velocity and acceleration of a particle, as well as the magnitude of velocity of the particle at time t is equal to 2 seconds. So we have to find velocity, acceleration and magnitude of velocity at time is equal to 2 seconds. Here the given thing is the position of the particle, that is R is equal to 3t I cap minus 2t square j cap plus 4k cap. Now how to find the velocity? We have position. We need to think like that. What is the given data? From the data, how can I use the given data in finding the required answer? Now the data is given, that is position is given. We need to find velocity. So velocity is nothing but the rate of change of position, and we can do d by dt of the r, which means dr by dt, that is differentiating the position with respect to time, we will get velocity. So d by dt of the r term is nothing but 3t I cap minus 2t square j cap plus 4k cap. So now here the operation is, we need to differentiate each and every term which is related with the time, that is t. So we have d by dt of 3t I is nothing but 3 is a constant, we can't differentiate it, and we have time t, so it is 3 into I cap. Next d by dt of 2t square j cap, which is nothing but 2 is constant, take it outside, and you have d by dt of t square, which is nothing but 2t. So differentiating t square, we will get 2t, and we can write it as 2t into j cap. So 2 into 2t is 4t j cap. So you get 3 I cap minus 4t j cap. So in this term, we do not have any time term, that is t is not there, and hence this entire term becomes 0, and we get velocity is 3 I cap minus 4t j cap. Next, we have to find acceleration. How to find acceleration? Rate of change of velocity. D by dt is nothing but rate of change of velocity. If we find, we will get acceleration. So d by dt of the velocity we now calculated, that is 3 I cap minus 4t j cap. Same thing we are substituting. Again let us differentiate this with respect to time. So 3 I cap, no time term, so this term becomes 0. And next we will get d by dt of 4t j cap. So we have 4 is a constant, we'll take it outside, and here time t term is there, so it becomes 1, and we get 4 j cap, and we have minus sign over here, we'll get minus 4 j cap. So the acceleration is minus 4 j cap. And one more task is there for us to find the magnitude of velocity when the time is 2 seconds. So the magnitude of velocity can be calculated by the formula root of p square plus q square, or root of a square plus b square. We have velocity is equal to 3 I cap minus 4t j cap, and at time t is equal to 2 seconds we have to find out. So it will be 3 I cap minus 4 into, in the place of t, I am writing 2 because it is given that at time 2 seconds we have to find. So 4 into 2 j cap. So what is 4 into 2? It is 8 j cap. So we get velocity 3 I cap minus 8 j cap. Now we have to find the magnitude. So velocity's magnitude can be calculated as root of a square plus b square. So a is nothing but 3, b is nothing but 8, and we will get root of 3 square plus 8 square. So we will get 3 3s are 9, 8 8s are 64. So we will get 9 plus 64 root of 73 meter per second. So this is the magnitude of velocity at time t is equal to 2 seconds. So our next problem is a cricket ball is thrown at a speed of 30 meter per second in a direction which makes an angle of 30 degree with the horizontal. A cricket ball is thrown with a velocity 30 meter per second which is making an angle with the horizontal that is 30 degree. What do we have to calculate? Here we have to calculate the maximum height of the ball reached, and the range of the ball, that is the maximum horizontal distance covered by the ball, and time taken by the projectile to reach the maximum height. We need to find out t, that is time taken by the projectile to reach the maximum height. So let us now write the given data first. So it is given speed is 30 meter per second. So u is equal to 30 meter per second and the ball is projected and it is making an angle 30 degree with the horizontal. So theta is equal to 30 with x-axis. We need to find height, range as well as time required to reach the maximum height. So the formula to find maximum height is u square sin square theta divided by 2g. So let us now substitute all the terms. U is nothing but 30. So 30 square sin square theta value is 30 again 30 degree divided by 2 into 9.8. Now what is the value of sin 30? Sin 30 is nothing but 1 by 2. So 1 by 2 is 0.5. We have sin square 0.5. So here what we have to do, 30 square is 900 and we have sin square 30 is 1 divided by 2 divided by 2 into 9.8. So 1 divided by 2 is nothing but 0.5. So 0.5 the whole square into 900 divided by 2 into 9.8. We will get the answer as 11.4795 meter. Since we are calculating the height, we have to write the unit meter. Next we are going to find the range. Range can be calculated as u square sin 2 theta divided by g. As we know the value of u is 30. So u square 30 square sin of 2 theta value is 30 degree. Here we have 30 square into sin 2 of theta value is 30 degree divided by g is 9.8. So 30 into 2 is 60. Sin 60 value is root 3 divided by 2. So simplifying that, multiplying with 900 divided by 9.8, we will get the answer 79.53 meter. Now we have to calculate what is the time required for the ball to reach the maximum height. That can be calculated by the formula u sin theta divided by g. That is 30 into sin 30 divided by 9.8. Sin 30 is 0.5 into 30 divided by 9.8. We will get 1.53 seconds. Next we have a projectile is fired in such a way that its horizontal range is equal to 3 times its maximum height. Horizontal range is equal to 3 times its maximum height. What is the angle of projection? We need to find theta. The condition is range is 3 times the maximum height. We have to find the theta value, that is the angle of projection. So we know range is given by u square sin 2 theta divided by g, which is equal to 3 times the maximum height. The formula to find maximum height is u square sin square theta divided by 2g. Let us now simplify this. So we have sin 2 theta is equal to, you can cancel g and g here, u square and u square here. So you remain with sin 2 theta, which is equal to 3 sin square theta divided by 2. Now what is the formula for sin 2 theta? Sin 2 theta is given by 2 sin theta cos theta. So let us now substitute in the place of sin 2 theta as 2 sin theta cos theta, which is equal to 3 of sin square theta divided by 2. So now you can cancel 1 sin theta and sin theta here and we remain with 2 cos theta is equal to 3 sin theta divided by 2. So that is what we have here, 2 cos theta is equal to 3 sin theta divided by 2. So we can multiply this 2 to the other side. So we get 2 cos theta, which is equal to 3 by 2 sin theta we have. So multiply this here, you will get 4 cos theta is equal to 3 sin theta, or we can write this as 4 divided by 3, bringing this to the other side, 4 divided by 3, which is equal to sin theta, transposing cos theta to the other side, we will get sin theta divided by cos theta. So it is nothing but 4 divided by 3 is equal to sin by cos is equal to tan theta. 4 by 3 is equal to tan theta. So we have theta is equal to tan inverse of 4 by 3. So what is tan inverse of 4 by 3? It is 1.333. So we get theta value as 53.13 with the x-axis. Since the object or the cricket ball is projected upwards, it is making an angle with the horizontal, and hence we are mentioning the condition with x-axis, the angle of projection is 53.13 degree. These are the few examples for numericals from the chapter Motion in a Plane. In the upcoming session, let us solve few more problems related to all these concepts what we have studied or learnt in this chapter. Until then, take care all of you. Thank you.